Our next new concept in programming that we're going to look at is the use of loops. There are a couple different kinds of loops that we can use when we are working in programming, but the one we're going to be focusing on today is going to be the for loop. Now, when we do a loop, what it means is we're going to execute or run the same line of code multiple times until the situation that determines our loop is done has completed. To look at the syntax for working with a loop, I'm just prepping some of these things here. Oh, gotta put a color in my background, make it happy. Alright, so my loop. The way that we do it. When we do a for loop, we start out with the word for. And what we're going to do is a for loop has what is referred to as an iterator or counter. And very commonly it uses the letter I as that. So we say int I equals 0. So we're going to start with I equals 0. Then we put a semicolon. So this is our counter. Then we're going to specify how many times we want this to run. So we create a conditional statement, and I say, well, I want this to run while I is less than, in this case, I'll just put in a number like 10. And then we specify how I is going to update. Now, what we normally do, it's an integer, so we typically go up by 1. We can also make loops that start not at 0 but start at our maximum value and count down. That's possible too, but that's less common. Now the convention for saying I want I to just go up 1 time each time this loop runs is we use plus plus. So in the past we said something like I is equal to I plus 1. Well, the shorthand way of writing I is equal to I is equal to I plus 1 is simply I plus plus. We can also use I minus minus if we wanted to keep subtracting 1. And it's just a super convenient shorthand when we're coding to use plus plus instead of I is equal to I plus 1 or I is equal to I minus 1. So I would recommend that you grow accustomed and comfortable using that. Now we have a curly brace, so I hit return twice, close out my curly brace, and up arrow once. Now I'm going to just assign a fill color, and with this I am going to draw 10 rectangles. Now the way that I'm going to do this is I'm going to offset them by some factor of this iterator or counter. I mean, even before we do that, I could just simply say print line I like this, and this will print it out to the console. So if I do this and hit run, what we will do is see some numbers appear down in the console where we see it is now continuing. Well, probably should just stop it so it doesn't run forever. And it start out, so 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happens is this loop is running over and over and over and over. If I take this loop, I'm just going to copy it, comment that one out. I'll just run it inside of setup so it just runs once to make it easier to see. So we can see it just does 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I could print, modify this and say I is equal to, and then I can join these together. So in quotes, this is a string, and I can join it using a plus sign and put that number with it. Now if we run it, I'll say it says I is equal to 0, I is equal to 1, all the way up to 9. So this loop runs, starts out at 0, and it will keep executing as long as I is less than 10. And because as it loops through, after the 9th, or goes through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we try and add 1 to it at the end of that. That makes it 10. Oh, too big, so then it doesn't run any longer. And now here, it ran one time because it's in my setup versus having it run multiple times in my draw, which for the purposes of loops, we probably don't need to have it in the draw because it will just keep redrawing it on screen, but we could. So we'll just leave that. Now, let's go back to this one. So instead of printing it out, what I want to do is I want to draw a rectangle. This time when I draw the rectangle, I want to maybe just start out the rectangle. I mean, if we just said 50, comma, 50, we're starting, I'll do 100. Oh, just realized, probably need a size up here. So, pardon the out of sequence code, but we do need a size so we can put these on it. So x at 50, y at 100, and we'll just make some be 50, 100, 50, 100. Let's see what that looks like. Okay, so we can see it made a rectangle. Just going to comment out the print there. We don't really need that anymore. So it made a single rectangle. I'll just leave that up while we're working here. But if we looked at this, we would see that it is not just one rectangle, but it's multiple rectangles. So if I offset this by, say, so we'll take 50 and then we'll add to it I times, now our box is 50 wide, so maybe I'll just go over 60. So the first time this runs, I is equal to 0. 0 times 60 will still be 0, so we'll see our one box here. The next time when I is equal to 1 times 60 will be 60. 60 plus 50 will be 110, so it should put our next box next to it. And then it will repeat that 10 times. This is the real power of working with loops. When we want to work with iterate over multiple items. So next we're going to be looking at arrays, which are a group of similar items, and it's kind of think of an array as a box or a container, and we can use a loop to then iterate over those to then update their positions, update their display so that everything can show up on screen. So working with loops, it's very specific on the syntax. We have a for. We got the parentheses that are the conditions for that loop. So we have our iterator, I, and then our condition for how long it's going to stay valid, and then how we want I to change each time we go through the loop. Because, I mean, if we said this, instead of just adding 1 to it, so if we said I is equal to I plus 2, now it's going to go through the loop half as many times. And if we wanted to just see, we'll just print out I to the console, take a look at it, we can see how now it's just going 0, 2, 4, 6 because we just keep adding 2 to it. What if we add 3? 0, 3, 6, 9, 0, 3, 6, 9. So we can see that it allows us to change how we iterate through that loop. But 90% of the time or more, it will just simply be plus plus. So we have our iterator, our condition we're looking for, how we increase that iterator, and then inside curly braces what we want to do. And we don't have to do anything with I while we go through this. We can simply just execute a code over and over multiple times. Now, a word about loops. Well, draw runs every 60 times per second approximately. This loop is going to run, so effectively, if this loop was super complex in what it was trying to do, it would stop our program while the loop runs. This is one of the things about working with loops is once we start a loop, we don't leave that loop until the condition is met. So if you create an infinite loop that can never end, it will crash your computer because we can't even get to the next frame because that loop will keep running and running and running. Processing is pretty good about telling us when that happens, and we'll say, hey, you've just made an infinite loop, we're going to stop doing stuff now. But once you start using loops, it is a good practice to save early and save often, because if you do accidentally create an infinite loop, then you're not going to watch your whole program go away when your computer crashes.